Yeah, let me check if this is working. Okay. Okay, cool. So, right. Okay. Hi, everyone, especially the ones who are watching on YouTube. So, as you can see, it's written here that you cannot access the live chat if you're watching it on YouTube. So, basically, what that means is the YouTube live chat that is there. I'm not reading that right now. I'm only reading the Unacademy live chat. So basically, if you want to interact with me by sending live messages or ask if you want to ask any doubts or anything like that, then you will have to be on the Unacademy app or on the Unacademy website, and then here there's a separate live chat which I'm reading right now. Okay, so hi Ardhendu, how to improve thinking ability and any tips? Yeah, I think with practice, I think with practice it improves automatically. Anyway, so this class is about string hashing, and yeah, so it is a special class in which I'll be teaching the concept behind string hashing, right? Okay, so in string hashing, basically what we do is we have a hashing function. Okay, and we have a certain string. Good evening, Prem. Okay, we have a string and we have a hashing function, and what happens is when we give this string to the hashing function, we get a thing that is called the hash. Okay. So in this way, from a string we can get a hash using a hashing function. Okay, so we will see good evening, Vardhaman. Okay, we will see how this is helpful. Why are we doing this? Why are we using this string hashing? And what is the use of this hash that we get? What we will do with it? And what kind of problems we can solve using this technique, and where is it useful? Okay, so out of the people who are watching right now, how many of you already know about this thing, this string hashing? Hello, Sarvesh. Okay, so let me tell you the itinerary of this class so that you can see whether it's for you or not. Okay, so this is the itinerary. Right. First of all, we start with all the basics. So we start with the basics. So basically, there are like almost no prerequisites. There are almost no prerequisites. Okay, except modular algebra. Okay, so you need to know modular algebra to understand the type of hashing that we'll be doing. So modular algebra, if you don't know much about it, what you can do is you can go to my Unacademy profile. There I've done a course on modular algebra. Shrijit just subscribed. Thank you for subscribing. Okay. Now almost no prerequisites are required, and except just modular algebra. So you can learn modular algebra from my profile. There's the lecture that I've done already on that thing. Anyway, so these are the basics that I'll cover. So I'll cover from the basics. You don't need to know anything about string. That's fine. Then we'll move on to the implementation, which is very important in this one, right? So there are a lot of different types of implementations which lead to different time complexities, and I'll be telling you which one is good, which one is bad, which one should you use, etc. Right? So based on all that, in this one, implementation is really important. Like whenever I'm teaching things, usually I don't focus much on Modular arithmetic or modular algebra. Yeah, modular arithmetic. Yeah, modular arithmetic. I don't know why I wrote algebra. I mean, that's the same thing, but that's fine. Modular arithmetic. Nothing too complex. Like even if you don't know this thing, you can still understand most of the part, I think. But anyway, more just the modular arithmetic. Okay. So now you have. I'll be discussing the implementation, and then I'll also be discussing some. mm I'll also be discussing some tricks, right? So with hashing, there are a lot of tricks, like a lot of tricks, and there are a lot of problems also that are involved. So issues, there are a lot of issues as well, and also how to solve them and how to solve them. Okay. So as I said, since there are a lot of different implementations of hashing, and since there are a lot of tricks, so because of all this, there are a lot of issues as well. So like there are a lot of problems that are caused due to string hashing. Like you can write the correct program and you can still get wrong answer or something like that. So we'll be seeing how to solve such issues, and the implementation that I will discuss. This will be everything will be linear. Okay, so everything will be linear in time. Everything will be linear, which means we won't be using modular inverses or binary exponentiation or anything, right? So everything will be linear. And yeah, so let's begin with the basics of hashing. Okay, so let's see in general what hashing is. Not just string hashing, just let's see what hashing is. Okay, let's see what hashing is. In hashing, what we do is we have some data. Okay, it can be any type of data. It can be a string, it can be some numbers, it can be an array or a set or anything, right? So we have some data, and what we do is we take the data, we pass it to a hashing function. Okay, and when we pass this data to the hashing function, we get a thing that is called the hash. Okay, so when you send the data to the hashing function, you get a hash, right? So let's see what are the requirements and what are the mm, like what are the necessities and what are the quality features of a hash, right? So there are some things that are necessary that a hashing function should uh, like should necessarily follow, and there are some things that are not necessary, but if they are followed, then it is a good hash function, right? So like a qualitative measure of how good a hashing function is, right? So basically, what is the let's first try to understand what is the um, key idea behind this. Why are we using a hashing function? Why are we converting the data into a hash? And what is the advantage of this thing, right? So basically, what we want to do is if we want to compare two things, whether they are equal or not, right? So basically, hashes are used for something like comparison, whether two data are equal or not. Okay. So it can compare whether if you have two different data, it can compare whether they are the same or they are not the same, right? But you would think that let's take the example of string. So let's say if we have two strings, these two strings if we have, then even without hashing we can check if they are equal or not, right? We can just run a loop and we can check character by character if all of them are equal or they are not equal, right? So we can do this without hashing also. then why are we using hashing? So can anybody tell me in the chat what could possibly be the benefit of doing all this? Like, why are we first sending our data to the hashing function, then we are hashing it. After that, we will compare the hashes to see if the two data are equal or not, when we can simply compare the data itself. Right? So Arjun has answered in the chat, it improves the time complexity, right? So yes, that is true. So basically, yeah, looking at n characters is bad. And yeah, so basically what we usually do is, um, the data can be vast. Okay, so there can be a lot of information in the data, so it is usually very vast. You can see, if you have a string, the string can be up to 10 to the power 6 characters long, it can be 10 to the power 7 character long, like it can be really big, right? So there is a lot of data there, it is very vast, and comparing the data directly can be really slow. So what we do is, when we send it to the hashing function, the hash that we get, this is small in size, basically small in size and easily comparable. Okay, so yeah, so basically what we're doing is, we're taking the vast data, we're sending it to the hashing function, and then we're getting a hash, and the hash is small in size, so it is easily comparable, right? So what we can do is, let's say if we had this string AABCD, what I will do is, I will just hash it, and let's say I don't know what my hashing function is doing, it is some hidden black box, so it is doing something, but from this string I am getting just a single number, let's say I am getting 18, right? So I'm just getting 18 from this, and let's say if I have another similar string, and if I pass it to the same hashing function, then again I will get 18. And to check if these two strings are equal or not, we are doing 5 operations, but here we are just doing one operation, we are just checking if 18 is equal to 18 or not, right? So if we can convert a very long string into a single integer, or maybe just 2 or 3 integers, then the comparison would be very quick, right? So that is the main idea of a hash, that is the advantage of it, right? But this small in size thing, it is not a necessity, it is just a qualitative measure, like the smaller it is, the better it is. But even if the hash is bigger than the data itself, then also it is not an invalid hash, it will be valid hash, but it will technically be useless, right? So let's see the necessities of a hash. Okay, so let's see what should be the necessity of a hash. What are the conditions that a hash must satisfy, a hashing function must satisfy, right? So same data gets hashed to same value, same data always produces same hash. And this is very necessary. So as I said, we have the string A, B, C, D, and when we hash it, we get 18. And then we hash the same string again, then also we should get 18. It's not like we are sending the same data a different number of times, and each time we are getting a different hash. Then it will be useless, right? So this is a necessity according to the definition of hashing. This is a necessary feature, that the same data should always produce the same hash. Okay, so this is a necessity. And then let's talk about the quality features, the features that improve the quality. Okay, so first is, size should be small. Okay, so basically same data always produces same hash, and the size should be small, size of the hash should be small. So something like, if we have A, B, C, D, we are getting just one integer from it, that is just but to get the hash we want but to get the hash won't we require linear time. How did we improve the time complexity? Yeah, it's all coming further, but I'll answer this doubt just now. So it's like, let's say you have a lot of strings, right? So let's say if you have hundreds of strings and you want to check if all of them are equal to each other or not, like something like that. So let's say you want to count the number of distinct strings that are present, right? So if you try to push everything in a set, what will happen is it will require n log n or something like that, like a lot of time, right? I think it will require n square log n, because mm, sorry, yeah. So let's say if you have n strings with l length each, it will require n into l log n. Okay, something like this. It will be really bad. But if you hash all the strings first and then push them in the set, it will be really better, right? So we'll see that later. There are many other things that make hashing much better. We'll see about that later, especially substring hashes. So once you reprocess a string, you can get the hash of a substring very quickly. So that is another advantage, right? So size should be small. If you are getting the size of the hash bigger than the string itself, then it is completely useless, right? And another thing is, now this is not always possible, but as far as possible, different strings hash to different value. Different strings produce different hash. Let's say different data produces different hash. And you can see that it is usually impossible for this thing to happen, right? Because let's say if you have a string of length 10 to power 5, then the total number of strings that can be made like this are 26 to power 10 to power 5, right? Which is definitely a lot greater than a single integer that you are storing this value into. Let's say if you want to store a single integer, it has only 2 to power 64 distinct values, right? It has only 2 to power 64 distinct values, but the total number of strings are a lot. So it is technically impossible to, get a hashing function that produces different hash for different data, right? So since it is impossible, so what we do is we say probability of collision is low. Probability of collision is low. Now what is a collision? Collision is basically nothing but, by the way, these things are like really easy. Don't get scared by all these things. These are just some concepts that you should keep in mind when we reach the actual implementation or the code or things like that. It will be really easy, so you don't have to worry about anything. Collision is just string hashing, same as hash maps. No, it's different. It's very different. Okay, so collision. String hashing is actually a very powerful tool. It's like one of the most powerful string algorithms. It can do a lot of stuff. You'll understand soon. Okay, so collision is like you have different data, but it produces same hash. But it produces same hash, right? So this is what you call a collision, and you want this thing to have a very low probability. Then only your hashing would work fine. Okay, so a collision is a case in which different data produces the same hash, but what you want to do is you want the probability of collision to be really low. Okay, so now let's see one hashing function that that satisfy all the necessities and one of the quality feature also, but it is practically useless. Okay, so let's say if I have a hashing function h such that no matter what the string is, so for all strings this h just hashes to the integer 0. Okay, so no matter what the string is, it hashes to 0, right? So what will happen is the size is small, so it's fulfilling one of the quality features, and same data always produces same hash because even different data is producing the same hash. So obviously it is fulfilling the necessity, but it is practically useless, right? There's no point of assigning 0 to all of the strings, right? Because you won't be able to compare anything. So here the probability of collision is 100%, which is really bad. Okay, so that's not what you want, right? Now let's try something else. Let's try a different type of hashing function. Let's try a hashing function that just adds the ASCII values. Okay, so let's say if you have two strings A, B, B, it will just be let's say A is 1 and B is 2 and so on, right? So it will be like 1 plus 1 plus 2 plus 2, so something like 6. And let's say if you have some other string like CD, right? So this will be equal to 3 plus 4, which is equal to 7, right? So in this way you can see that the collision probability is slightly lesser, but there are still a lot of ways to perform collisions, like anagrams. So as Hitesh pointed out in the chat, anagrams will always have the same hash, right? So if you have AABB, the hash of AABB will be the same as the hash of ABAB, which will be the same as hash of BBAA, right? So even this hashing function is kind of useless, and it has a lot of different ways of collisions, and we don't want a lot of collisions, right? So this is also a bad hash, right? So how can we come up with a better hash? So this hash function that I'm going to talk about is called the polynomial rolling hash. It is a very nice function, and it has very low collision probability. Okay, so this is called the polynomial rolling hash. And whenever somebody talks about string hash, he basically means this thing only. Okay. Right, so let's see this polynomial rolling hash, which is also called the string hash. In this, what we do is, if we have a string like this A, B, C, D, we have a certain value that is called the base. Okay, we have a base, and for now let's say just the base is like 35 or something. Okay, let's say it is 31. Okay, so what we will do is, or let's just call the base B. Okay, we cannot call it B. I'll just call it capital B. Okay, so let's say the base is capital B, which is maybe say 31 or any integer. Okay, so I mean, like we'll see which base is better, what kind of base you should choose. But for now, let's just say 31, and I'll denote it as capital B. Now to hash this string, first of all, let's convert it into values like A is 1, B is 2, C is 3, and D is 4. Actually, you can directly use the ASCII values, which will give you 97, 98, 99, etc. and 100. That's fine. You can use any of these values, right? So basically, each character has a different value. Let's say these are 1, 2, 3, 4. What we will do here is we will write the indices also, right? So like the index of this is 0, this is 1, this is 2, and this is 3. These are just the indices of characters. Let me have another few more characters here to explain properly, that there are no doubts remaining, right? So these are the values and these are the indices. Okay. From 0 to 5 we have indices, and these are the values, like A is the first character, B is the second, C is the third, and so on, right? Now what we will do is we will make a polynomial kind of thing using this, where these things will be the coefficients, and this will be the power of b. B is the variable, right? So let me show you what we're doing. It is something like we have these values, right? So let me write it here only. So we will have something like 1 multiplied by b to power 0 plus 2 multiplied by b to power 1 plus 3 multiplied by b square plus 4 multiplied by b cube plus 1 multiplied by b to power 4 plus 1 multiplied by b to power 5, right? So do you understand like how I'm writing the hash from this string? It is pretty simple. It's something like the hash of string s is nothing but the summation of I equal to 0 till the length of the string minus 1. And what are we doing the summation of? Nothing, just the character si multiplied by b to power I, where b is the base. Okay, so do you guys understand what this hash function is? You don't necessarily need to understand why is this good, and we'll see that in a few moments. So just give me a thumbs up if you understand, if you can solve at least this problem, that I have given you the base and I have given you a string and I ask you to find the hash, polynomial rolling hash of the string. Okay, so there are a lot of advantages of such a hashing function, which is the polynomial hash, rolling hash. There are a lot of advantages of this. We will see very soon what are the advantages. There are actually a lot of advantages. Just wait a second. Okay, just a second. Okay, guys, I'm actually not reading the YouTube chat. Like I'm reading just now, but there are a lot of messages here. I'm not reading it, so I won't be able to reply regularly. If you want to live chat, you can come on the Unacademy platform. The details are here. Okay. Right. So this is how you get a polynomial rolling hash, right? And the good thing here is that it doesn't collide very easily, right? But for that, the base has to be bigger than the size of alphabet, right? So let's see what that means. So basically, if base is very small, let's say if base is 2, then you can easily have a collision because basically, I think most of you already understand why this is happening. But let's say if we have the string AA, it will get hash to 1 plus 2, which is 3, and C also gets hash to 3, right? So basically, if the base is small, then the strings will obviously get hash to the same value, but we want the base to be big. So base should be greater than size of alphabet. Right, that's fine. Okay, but now there is another problem. Let's say that the string is big. Okay, so let's say the length of the string is somewhere around 10 to power 5, right? So b to power 10 to power 5 will be like very big, bigger than 2 to power 64, which is the range of an integer. So how do we circumvent this problem? What do we do to avoid this thing? We can take modulo some huge number, right? Exactly. So we take mod some big number. So we calculate this hash in the modulo. Just a second. Okay. So we calculate this hash modulo some big number, which should be preferably prime. So we'll discuss later why this should be prime. What is the advantage of having such a mod prime, and why can't we work with a composite number? Like we can work with a composite number, but it doesn't work very well. So we'll discuss that later. For now, let's just say that we take a big prime, and yeah. So the thing that is happening here is, if you have a suitable base and you get this string, so it will probably exceed m. Like it will probably exceed capital M, and you will have something really big. So you will have a really big number, right? So there's no way to guess what that number will be, right? I mean, you can guess that thing, but like if you don't know much about the string, there's no way to guess that thing, right? So it can be any of the numbers from 0 to n minus 1. So hash belongs to the range 0 till m minus 1, that is true, but you don't know which exact value it will be. So because of this, what happens is, it is equiprobable that this can take any of the values, right? So the hash take each of these values equiprobably. Okay, so all of these values are equiprobable. Uh, Equiprobable. Okay, right. So all of these values are equiprobable, right? So if you have two different strings, the probability that they will collide is very less, and it is 1 by m. Okay, the probability. Can you guys understand what how I got this result? Can anybody explain in the chat how I got this result? That the probability that two different strings will hash to the same value is 1 by m. If you take two random strings and you basically take the hash of both of the strings, then the probability that they will be same is 1 by m. How can we say that it will be equiprobable so assuredly? Yeah, so basically the reason here is that it is prime. So since it is prime, that's why it will be equiprobable. If it is not prime, then it won't be equiprobable. We'll see that later. For now, you can just assume that the hash is equiprobable in the entire space. It actually comes from extract algebra, etc. Because like if you have a ring and then you exceed that thing, so like you don't need to care about that. You just know that this is equiprobable if m is prime. So if m is prime, then it is equiprobable. 1 by m is the probability that a certain value, a certain string takes a certain value, right? So if you take a random string, the probability that its value will be 7, the probability that it will get hashed to 7 is 1 by m. The probability that it will get hashed to 8 will also be 1 by m, right? So it's something like that. So the probability of collision will be m by m square, right? So it will be m by m square. And let's see why. Because it is same as two people having the same birthday, right? So what is the probability that if you take a random person, his birthday is on 1st January? It is just 1 by 365. What is the probability that his birthday will be on 1 February? That is also 1 by 365, and so on. So on every day, the probability that it will be his birthday is 1 by 365. Now if you take two random people, there are 365 square ways of having all the different pairs of birthdays, and out of them 365 are favorable, because like if both are born on 1 January, that's fine. If both are born on 2 January, that's fine, and so on. So 365 are favorable and 365 are total, and if you cancel them, so you again get 1 by 365. So if you take two random people, the probability that their birthday will be same is 1 by 365, right? So similarly, if you take two different strings, the probability that they will get hashed to the same value is just 1 by m, which is usually very small. So it is usually very small. let's say if you take m equal to 10 to power 9 plus 7, then the probability of collision will be 0.0000000, something like that. So very less probability of collision, right? So that's fine. Now a lot of maths already. Let's try to see how this is useful, right? So what we can do is, so first use this to just compare the strings, right? So let's say if you have a lot of strings, what you can do is you can hash all of them, and in just linear time you can hash all the strings. So you can use the polynomial rolling hash function to get hash of a string, right? So in this way, in linear time, you'll read each string one by one, and you will get the hash of each string like this, right? Now, if you want to count the total number of distinct strings, you can just put all of these hashes in a set, and then the number of distinct elements in the set will give you the distinct number of strings, right? But this is not very useful. So it would be better if we could get the hashes of the substrings as well, right? So yes, we can get the hash of substring as well, and that makes this polynomial rolling hash very powerful. Okay, so now let's see substring hash. So this is the main power of a polynomial rolling hash function. And before I start explaining this, let's try to see what is the problem that we're going to solve using this. Okay, so the problem is simple. Let's say if you have two strings, right? So you have one string that is very long, and then you have another string that is also very long. Right? So let's say these are actually very long strings. Like this can also be 10 to power 5. This can also be 10 to power 5. Right? So you have two very long strings, and then you have Q queries. Okay. So Q queries. And Q is also around 10 to power 5. And in each query, you get L1 R1 and L2 R2. I think most of you understand what is the problem that I am going to pose right now. So what L1 R1 is, you will have something like this, that is L1 R1. Okay. And L2 R2 will be something like this. You have L2 here, R2 here. Okay. And you have to answer yes or no whether this thing is the same as this thing or not, right? So does everybody understand the question? Give me a thumbs up if you understand the problem. Okay. So can anybody tell me what will be the time complexity of the solution if you try to do this naively, like without string hashing? If you try to do it, what will be the time complexity of this solution? The length of these strings is, let's say, n. Both of these strings are n in length. Length of the strings is n, and the number of queries are q. Right. So the time complexity will be right. Okay, I'll write this. So I'm getting most of the correct answers, but like some are answering some part, some are answering some other part. So the time complexity is the minimum of nq comma n square. Let's see why. So n square is pretty simple. What you can do is you can already, no, not n square, sorry, it's just nq. It is nq, right? So the time complexity is nq. What you're doing is for each query, you're taking that interval L1 comma R1 and L2 comma R2. What you're doing is you're comparing if these two are same or not, which will take R1 minus L1 time, and this is On time. So yeah, in O of nq you can solve this problem, right? And this can be really slow if both n and q are 10 to the power 5. So this will give you TLE. Right? Now using string hashing, we can optimize this thing to just O of Q, right? So it will become O of N plus Q using hashing. So using hashing, we will be able to do this thing in O of N plus Q, and let's see how we will do it. Okay. So the pathway is kind of simple. What we want to do is we want to perform some pre-computation on this string so that we can get the hash of any substring in this constant time, and we want to do same pre-processing on this string as well so that in constant time we can get the hash of any substring. And using these two things, we will be able to solve it in O of N plus Q time. Okay, so everybody understand that if we can get the substring hash in O1 time, we will be able to do this. Now the only thing that is left is to get the substring hash in O1 time, right? So do you understand this part? Right. Okay. So now the only problem that is left is how to get it in O1 time. So how to get the substring hash in O1 time? That is the problem that we still haven't solved. Okay. So for this, let's try to see the definition of this hash. Okay. So what we're doing in this is we're multiplying the characters with b to power I, and we're summing everything up. Okay. So for example, if we had a string like this, a b something like this, let's take one more time. Okay, so the string would look something like instead of writing a as 1, I'll just write a. So it is a plus b into base plus a into base square plus b into base cube plus a into base to power 4 and so on, right? Something like this. So this is the hash of the string. And let's say if we want the hash of a certain prefix, then that is simple. You just want this value, right? So if you perform the prefix sum, like if you like this, this you take a, this you take bb, this you take ab square, bb cube, and so on. And if you perform the prefix sum on this, so any prefix will give you the hash of a hash of that prefix string, right? So do you understand how to get the hash of a prefix? Right? So you understand how to get the hash of a prefix. But how do we get the hash of a string that occurs in between like this? So for that, let's try to write the value of this. So this hash will be nothing but a plus bb plus ab square, right? And if you look at this part carefully, then this thing multiplied by b square is this thing. Agree? So do you guys understand that this thing is just this thing multiplied, like this thing is just this thing multiplied by b square? I mean, look at it carefully. If you multiply b square everywhere, you will get this thing back. Right? So give me a thumbs up if you understand this. Okay, so if we have maintained the prefix sum of the hash, like if we have maintained this kind of prefix sum, so let's say this array p is storing the prefix sum till x. Okay, so this is the prefix sum till x. So answer me in the chat, how will you get the yes, you can use inverse modulo, right? So you can use inverse modulo, but my question is, how will you get the answer till answer of L till R? Yeah, we'll talk about it. For now, you can use inverse modulo, but I will tell you the tricks. As I said in the beginning, the itinerary, that there are tricks that are involved, right? So I said there are tricks, so I'll tell you how to improve it to work without the log of the inverse, right? But for now, let's just solve this part. Wait a second, I lost the slide where we were on. Okay. Prefix till R divided by B to power L divide by P to power I. Right. So a lot of answers that I'm getting are like somebody got some part right, somebody got some part wrong, some part right, some part wrong, etc. Right. So I will just write the exactly correct thing so that you can match with your solution. So to get the hash for L comma R, you just have to do something like P of R minus P of L minus 1, right? And now you have to divide it by what? P to power L, right? Now you divide it by P to power L. Sorry, B to power L, right? Then you divide it by B to power L, or it is the same as multiplying it with the inverse of B to power L. Okay, B to power L inverse, right? So everybody gets this part, right? So everybody made a little bit mistake. You can match this thing with your solution, and you can see what your mistake was. Okay, right. So in this way, we can get the but you cannot calculate pre-L minus 1 for 0th index. Yeah, we make the hash one based indexing. Like we do one based index. So like you can do one based indexing. So to make sure. So basically, Adhendu is saying that if L equals 0, then you cannot get this thing P of L minus 1. So there are a lot of things that you can do. You can make a function for getting the subhash, and in that you can subtract this thing if and only if like that thing is happening. Like you can subtract this if and only if L is greater than 0. And so there are a lot of ways to circumvent that problem. That is fine. But yeah, so to get this inverse, it works in log of m time, right? So for now, it won't work in O of n plus q time. It will work in O of n plus q log m time, right? So it will work in O of n plus q log of n, log of n, right? But even that is fine because even if you do this, it will still work, right? So that is the cool thing that you are at least able to solve this problem. Now there are multiple ways to optimize this and remove this log m, right? So there are a lot of ways to remove this log m. Let's try to see a few of them. Okay. So how to remove this? Can anybody answer this? How to remove this? Right. So I already got one correct answer. There are other ways as well. Right. So one of the correct ways that I already got. What do you mean, Hitesh? Can you explain it out? Okay, just a second. Right. Anyway, so to remove this log m, one way to do is we can pre-compute the directly dividing by b to power n. This is actually modular arithmetic. This is not the normal arithmetic. So yeah, we're working in mods, right? So everything is in mod m. Anyway, maybe you're not familiar with modular arithmetic. Okay, so to remove this thing, what we can do is pre-compute. We can just pre-compute all. We can pre-compute all the b to power L inverse. Sorry, b to power L inverse. We can compute for each L, right? So we can compute all this for each L, and we can do it in like in like not much time. It's easy to do it, right? Because find the b to power L inverse for the biggest value, then keep on multiplying b, so you get the b to power L for smaller values, and you can store all of that in an array, and in this way we can remove the log m. So yeah, that will work, and that's it. So in this way you can get the substring hash in just one time, and then you can solve this problem easily in just n plus q time, right? Everybody understands this? Okay, right. Okay, now let's see a few other things. So a lot of it is still left, like it's not like we have already done a lot of stuff. Like we have already done a lot of stuff, but it's not like it's over. There's a lot of concepts that are still left regarding string hashing. Okay, so we'll see them one by one. But yeah, let's see what we have learned till now. Okay, so till now we can do O of n pre-computation, and just using this O of n pre-computation we can get any substring hash. We can get any substring hash in O of 1, and we can compare hashes in O of 1. So this already is like very powerful. You can do a lot of stuff with using just this these things, right? So let's take an example. I'll give you a problem, and you have to it's not like very simple. You have to think out of the box for this one, but you have to answer this. Okay. So you are given a string. Okay. Like something like this, and you have q queries. In each query you are given L comma R, right? So something like this. Okay, and you have to answer yes or no, and you have to answer yes if it is a palindrome and no if it is not a palindrome. Okay, so you have to answer yes or no whether it is palindrome. Okay, so how can we do this? How can we answer quickly to yes or no whether a given substring is palindrome or not? Okay, so anybody has any idea how we can do this? Instead of having two strings, this time only we only have one string. What should we do? Yes, yes, exactly. Compare hash of left part and right part. No, 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 not that. That's not. But I have two correct answers. So one is forward and backward hashing, and the other is pre-compute two hashes, one of the original string and one of the reverse string. Right. So let me explain this one first. So basically, you have this string. What you do is you reverse this string, so you get another string that way, right? So this way you have two strings, and from this L comma R you can get L2 comma R2, right? So that's not very difficult. You know that this segment in this will represent this segment in this. Okay, so you can easily get which segment it is representing just by subtracting something something and minus something something. You'll be able to get it. Like you know that this segment is the same as this segment, right? And then you can you can just compare the entire thing. You can just compare this hash and this hash. That's it. They should be equal, right? So let's say if you had something like this and you have this, so you just compare if these two are equal or not, and that's enough. You don't have to make it half or anything like that. Just compare the full things. And again you can do it in O of n plus q time. Yeah, so again you can do it in O of n plus q time by taking another reverse string, right? So another way is what Ardhendu pointed out. Instead of actually reversing the string, we consider the reverse hash of the string, right? So we already had one hash, that is like a plus bb plus ab square plus cb cube plus ab to power 4 and so on, right? So this hash we call the forward hash. Okay. Similarly, we can make a reverse hash of this string. That will be like d plus b plus xb square plus yb cube and so on, right? So this other hash we will make it in reverse direction and we call it backward hash. And now it is even easier. Now what we have to do is we just have to check if the forward and the backward hash are same or not, right? So do you guys get this one? Give me a thumbs up if you understand this. Okay, cool. So yeah, so this is the way of getting whether it is palindrome or not. Now let's take another good problem. So it is something like, again, I'll just use this slide, this string only. Let's say if you have a string again, something like this. Okay, so again you have a certain string, and what you want to do is you are given okay, you are not given anything else, you are just given this string and you want to find the longest palindrome in this entire string, right? So first of all, there is an algorithm called the manager algorithm that can do it in linear times. That is the best thing there. But like a lot of times, let's say if you don't have the code for manager algorithm and you are in some on-site competition, then you can use hashing also, right? So using hashing, you want to tell the longest palindrome in the entire string. Like for example, in this string, the longest palindrome is this. Actually, एक दिन मैंने लेक्चर भी पढ़ा दो. Actually, मुझे भी बहुत अच्छे से आता नहीं है लेक्चर. Like I have never used it. I have used it once, but I copy pasted the code. So even I'm not very good at manager. I don't fully understand it, how it works. Yeah, I don't fully understand how it works. Yeah, yeah. Like it's true. You should know manager algorithm as well. But yeah, you can do the same thing using hashing also. So how do you get the longest palindrome in the entire string using hashing? Can anybody think of anything? Actually, it's not very easy, so I'll be telling it on my own. Okay. So what we do here is we iterate on the center. So I'm gonna tell only for one way would be to compare forward and backward hashes for all L, R. Yeah, but that will be n square, right? So we don't want n square because obviously n square is really slow. N square we can do using DP also, so no point of using hashing. N square is easy without hashing as well. Anyway, so using hashing, what we do is we iterate on the center. Let's say this is the center. Okay, so we iterate on the center. Let's say this is the center of the palindrome, and right. So there are two types of palindromes: even palindromes and odd palindromes. So even palindromes will have an empty center like this. An odd palindrome would have a single character as the center. Okay. Now the cool thing about palindromes is if like let's say there is a palindrome of length 5 from this center, right? So there is a palindrome of length 5 and it is centered here, right? So the cool thing about palindromes is if you have a palindrome of length 5 at this center, you will also have a palindrome of length 3 at this center. Okay, are you getting it? If you have a palindrome of length 5, you automatically have a palindrome of length 3 also. Okay. So yeah. So with the basic idea is to we will just binary search this length, the like from each center, binary search the longest palindrome. Okay. So it is something like by the way, let's say there's a z here also, right? So let's say we try to binary search this thing, right? So first of all, we check whether the palindrome of length, like whether we have a palindrome of length 7 from this center or not, right? So what we will do is we will binary search this thing. So it will be something like we will take a string of length 7 from this center and we will check if it is palindrome or not. So this is not palindrome because this y is not the same as this z, right? So in binary search we will go to a smaller value like let's say 3, right? So now we will check for 3. For 3 it is palindrome, so we will go to a bigger value, let's say 5, and for 5 also it is palindrome, so we get that 5 is the smallest value, 5 is the biggest value for this center, such that there's a palindrome of that length here. Okay, so everybody understands this approach, and this will in total be O of n log n, because you are using this log n for the binary search and you are iterating on all centers. Okay, so from all center you are doing the binary search and the check of the binary search is just working in constant time. So it is O of n log n in total, and in that way you can get the longest palindrome from each center. So in total you can get the longest palindrome of this thing, right? So let's move forward. Now we have another thing. Okay, so this one is easy. I think almost everyone should be able to solve it. So give it a try. Okay, so you have a string. Okay, so you have a string, and if you okay, okay, thanks. Okay, okay. So if you have this, if you have a string like this, and if you try to write all the substrings, they will look something like this: A B, A B C, A B C, D A B, A like so, like a lot of things like this, right? And then the strings that are starting from B, like this, and a lot of strings that are starting from C, and then a lot of strings starting from D, and so on, right? But not all of them are distinct. You see that this AB is repeated, and this B is also repeated. So you can see that this and this are same, this and this are same, this and this are same, and so on, right? So you can see that can be a lot of substrings, but not all are distinct, right? So you are given a string, the length is not very much. Let's say the length is just till 1000. Okay, so length is just till 1000, but there are like you want to check the total number of distinct substrings. Okay, so the problem is count number of distinct substrings. How will you do this? This is not difficult, this is easy. This should be easy. Okay, so can anybody answer that? It's very easy actually. Okay, at least give me a thumbs up if you understand the problem. Yes, I got the correct answer already. Okay, it's like count number of distinct substrings. So yeah, simple. Since n is not very big, you can just you can iterate on all the subarrays, and for each subarray you can find the hash of that, and yeah, so you can find the hash of each subarray. So they won't be more than 10 to the power 6, even less than 10 to the power 6 actually. But yeah, they won't be more than 10 to the power 6. You can put all of them in the set, and then the size of the set will be the answer. Okay. So yeah, you can do this thing. But now let's talk about the issues. Okay, so we have covered most of the, let's go back to the itinerary. No, it won't give you MLE, it won't give you MLE. Just 10 to the power 6 numbers, they won't give you an MLE. Set of size 10 to the power 6, that's fine. Okay, so we have already covered the basics, we haven't covered the implementation yet. We'll see some more tricks. Although we have seen a few, but yeah, let's see the first issue that we have right now. Okay, so it is a very you think that this is a very off-topic thing, but yeah, it is relevant. Okay, this is a thing called birthday paradox. Okay. Okay, so there is a thing called birthday paradox, and I'll tell you what that basically is. It's not really a paradox, but it's something like, let's say you have around 21 people. You have 21 people in a room. Yes, yes, almost all string hashing approaches are hackable, but we will see how you can avoid that. We will see how you can avoid being hacked. Okay, so you have 21 people in a room, and right. So let's say if you have 21 people in a room, and earlier we discussed that the probability that two people have the birthday on the same day is 1 by 365. Right. So this is not much. 1 by 365 is not definitely not a lot. So if you have 21 people in a room, what do you think should be the probability that at least two people have the same birthday, right? So I'm gonna do a poll. Like obviously it's not you don't have to calculate it. You just have to make a guess, right? So the guess is like less than 20%, less than 40%, less than 60%, less than 80%, and even lesser than, let's say, 5%, because 1 by 365 is very less, right? So I'm going to do a poll, and you just have to make a guess. If you have 21 people in a room, what is the probability that at least 2 of them have the birthday on the same day? Okay, so very mixed results of the poll. Everybody has answered different things. But yeah, so this is the answer. You get around, like you get more than 50% probability. You get more than 50% probability that 2 people have the same birthday if you have 21 random people in a room, right? So what you can do is you can check it in your school or anything. So like if you have a class of 21 people and if you ask the birthday of everyone, there's a good chance that at least 2 of them will be having the birthday on the same day, right? Even though there are a lot of days. So how is this relevant to the hashing thing, right? So it is like you have 10 to power 6 hashes. Right? So in this problem, you have 10 to the power 6 hashes. The probability of 2 hashes colliding is very less, just 10 to the power minus 9. Right? It is very less. The probability of 2 hashes colliding is very less. But since you have 10 to the power 6 hashes, the birthday paradox applies here, and there is almost like it is almost certain that at least 2 of them will be colliding, right? So if you use this problem, like if you use this approach for counting the number of distinct substrings, it will definitely give you, like it will most probably give you a wrong answer, because at least 2 of them will collide, right? This is just the birthday paradox. And usually what we want is, we want the number of pairs, or let's say the number of hashes, the total number of hashes that have to be compared, we want that to be smaller equal to square root of 1 by p, where p is the probability of collision, right? So you don't have to care much about it. Basically, we want to increase this probability. We want to decrease this probability of collision, right? We want a very we want a better probability of collision, right? So currently our probability of collision was just 1 by the 10 to the power 9 plus 7, and we want to improve this. To improve this, there are 2 ways. One way is to pick bigger prime. Right, so you pick a very big prime. Let's say you pick a prime that is of the order of 10 to the power 18, 10 to the power 18 plus something. Let's say this is a prime. So that way you will get 10 to the power minus 18 probability of collision. That is fine, that will work. But there are some issues with this, basically slower calculations. And if you have two very big numbers, if you multiply them, then that's an issue. So yeah, there are some problems with picking the bigger prime. So what we usually do is we take multiple hashes. We take multiple hashes. So multiple hashes mean that you have 2 different hashing functions. Let's say you have h1 as well and you have h2 as well, right? So both of them are hashing functions, and you have a certain string. You pass this to the hashing function, you get a certain hash, that is x. You pass this to the hashing function, you get another hash, that is y. And then you make a pair of these hashes. So you combine all of them, you get a pair x comma y, and you say that this is the hash of that string. And in this, what happens is the probability of collision gets multiplied. So the probability of collision of this will be p1 into p2, right? So yeah, this is quite simple. What you just want to do is you want to have 2 separate bases or maybe two separate modulos, or the same modulo or anything, right? So usually I prefer two different bases, something like I have B1 and B2, right? So if I have the string A, B, A, C, something like this, so one of the hashes will be like this: A plus B B1 plus A B1 square plus C B1 cube, and the other hash will be like A plus B B2 plus A B2 square plus C B2 cube, right? And then I will make a pair of these two things. Now this entire thing has to be same, right? So yeah, this works very well, and this is the this technique is called doing multiple hashes. So if you do multiple hash, then this thing will be fine. Then you can solve this problem, right? Because now your probability of collision is smaller. It is just 10 to the power minus 18, and now this will work. So a lot of times you have to do multiple hashes to avoid this thing. To avoid collisions, you have to do multiple hashes, right? So everybody understands this. I know it was a bit complex, but you don't really have to do it every time. You can just write a function that prepares, you can write a structure or a function, something like that, that prepares the hash of a string, and you can use it every time, right? So you just have to implement it once in your life, and you don't have to worry about it much, right? Okay. Hmm. So I'm going to show you a small code in which they have done the polynomial rolling hashing. Okay. Please provide the template in GitHub. And can't do it today, but I'll do it. You can find the hashing code from a lot of places, right? So there are a lot of coders who have their own hashing function. You can copy anyone's. But yeah, this is from the CP algorithms, right? So basically, this is like the very simple part of this thing, like not even processing the substring hashes, but you can see that they have a constant p and they have m, right? So this is the base, this is the modulo. Okay, they have the hash value which they will return, and they go to each character. They take the value of that character, multiply it to the base to power whatever index it is currently, because they are multiplying p power to p every time, and they keep adding it. So basically, this gives the hash, right? But it's not doing any tricks. Like it's not even storing the substring hashes or anything. Right, so I'll show you the code which does the substring hash also. Okay, it's not present here. Wait a second. I'll show you my own code then. It's be somewhere here. Okay. Okay, I did this without hash. I don't remember any problem that was done using hashing, so I'm having some trouble finding my code. It's also prefix function. Someone must have used hashing. Just wait 2 minutes. I'll show you the code. Mhm. Array. Oh no. Um, just a second. Okay, just 1 minute. I'll show you. Ah, mm, mm, okay, I can't really find it right now. Multiple hashing template. Just wait a minute. Let me just find some. I don't remember any problem in which, like, I remember a lot of hash problems, but I have done all of them using some deterministic solution. Like I've either used try or that I've either used try or z function or prefix function or something like that. So I can't find any of the problems where I have actually used hashing. Wait a second, there was a tag hashing. Okay, just 2 minutes. I'll share the code. You'll be able to copy it as well. Uh, Prefix suffix palindrome. Yeah, this one was nice. Okay, fine. Finally, I found it. But a lot of people had used hashing in this one. Copy anyone's. Wait a second. Okay. Yeah, I have my own code also. I think everybody had has done hashing in this contest. Except me. Just a minute. Okay, I can't really find a very good template, but I'll at least show some code. Just again. Yeah, I'll show you one problem that you can try. Okay. Okay. Yeah, check this problem out. Prefix suffix palindrome. So this was in global round 7, Codeforces. Yeah, a lot of people had used hashing for this, and yeah, so you can check this problem out. Just a second, and let me show you the code also. Just mm, okay. I have so many people done it. Manager, manager, whatever. Okay, right. I have to show this one only. Okay, cool. Just a second. Okay, I have the code. Okay, right. So I've shared the paste bin here. You can check it out. This is the code for string hashing. It has an entire structure. You can use the constructor to make the hash of the string quickly. And then, yeah, easy to work with that. Okay, anyway, let's see this problem. So this is the hard version of the problem. The easier version could have been done without even using hashing. So the difference is the constraint of the sum of lengths, etc. Right, so you are given a string s, and it consists of lowercase English letters, and you want to find the longest string t which satisfies the following conditions. So it is a palindrome, and there exist two strings a and b, possibly empty, such that t equals a plus b, and a is the prefix of s, while b is the suffix of s. Right? So basically, you want to take a prefix of t. Sorry, you are given a string s, and you want to build t in a way that you take a prefix of s and you take a suffix of x, and then you merge both of them, and that's in that way you get a palindrome. So that's what you want to do, and how can you do it? So that is the problem. Can anybody think of an approach here? Hmm, right. Okay. Right. So can anybody think of an approach here? So it is something like, let's say if you have a string a b x y x, then you have something like z p q, then again you have b a, right? Then what you can do is you can take this part and this part and this part, right? So basically if you join all of these, you'll get A, B, X, Y, X, B, A. It is definitely a palindrome, right? So what's happening here is, right, so this is the reverse of this, that is fine. But here you are taking the longest palindrome that is present, right? So here you are taking the longest palindrome that is present, or you can have taken here as well, right? So basically what you want to do is like start iterating from the on all prefixes, right? Let's say if I talk about this prefix, so what I want to do is I want to first check if this is same as this the reverse of this suffix or not, right? So this thing we can do using subhash, using hashing easily, right? So using hashing and reverse hashing, this can be done easily, right? So using hashing and reverse hashing, this part can be done easily. 2-pointer, yeah, right. With 2-pointer also you can do it, so that's fine. Why am I saying hashing? With 2-pointer also you can do if this is same as this or not, right? But what you want to do is you want to get the longest palindrome at one of the ends, right? So using hashing or 2-pointer you can tell that this and this are same or not, but you want either the longest palindrome from here or the longest palindrome from here, right? So how do we get the longest palindrome that ends somewhere here, right? So for that we use this hashing thing, right? So using hashing we can get the longest palindrome at any center, right? So using string hashing we can get the longest palindrome from any center. Like from here I know that there's a palindrome of length 3, so this means that this entire thing is a palindrome, right? So by getting these longest palindromes like this, it is easy to get the longest palindrome starting from a certain value as well, right? How can we do that? Many ways to do it. One way is again binary search. If I have to check whether there is a palindrome here of length 3 or not, at least length 3 or not, so what I can do is I can check if for this 3 on the center there should be a palindrome of 3 or more, right? Something like this we can do. So yeah, there are multiple ways to do this. Once you have made the longest palindromic substring array, which we can make using binary search and hashing that we talked about earlier, like at each point we will know the longest palindrome that is present here. Like from here it is 1 1 1 3 1 1 1 1 1 1, right? So if there's a 3 here, that means if you start here you get a palindrome of length 3. So if we had something like x y z y x, so we have a 5 here, right? So if we have a 5 here, that means here we have a palindrome of length 3, here we have a palindrome of length 5, and so on. So these things we can store, and once we have done this, it is quite simple, right? So that's how you could have solved this problem. Okay, so I have shown you the code, but still I will talk a little bit about the implementation. Like if I had to write it from the scratch, how would I do it? Okay, so usually what I do is I take an array for I call an array H, right? This is for the prefix sum of hash, for the prefix hash basically, right? Then I pre-compute the powers. So I have a p to power n, which is basically pre-compute base powers. Okay, so it stores all the powers of bases. Like if you have the base, it stores all the powers like this. And yeah, you can also store the inverse. So you can have the inverse of p like this, power n. You can store that as well, like inverse of base powers. Right? So if you have all of these things pre-computed, it becomes quite easy. Now to pre-compute this, it's not very difficult. You just use this definition that we talked about here, and just by using this definition you can easily pre-compute it. So what we will do here is, right, so we will run a loop. If we have a string s of length n, we will run a loop of I equal to 0 to n minus 1, and simply we will do something like h of I equals h of I minus 1 plus, and by the way this won't work if I equals 0. So you add this part if I is greater than 0, right? And here we have to add something like the character that is present there, si, multiplied by the power p to power I, and then you do mod m, right? So m is the whatever you have, 10 to the power 9 plus 7 or anything, right? If you have multiple hashes, you can have something like h1 h2, then you can have m1 m2, you can solve them separately like that. So yeah, that also you can do, and that's it. So basically like this you can store the entire hash. And let's say if you want the sub hash, right, so int sub hash will be something like, if you have l comma r, sub hash is pretty easy. Let's say the answer equals h of r. Now if l is greater than 0, then you do answer equals answer plus m minus h of l minus 1 multiplied by the inverse power of l, and everything you take mod m, right? And you have to take mod m before subtracting this also. So right, and yeah, simply then you return answer. Right. So yeah, so that's how you do it. And right. So basically, yeah. So that's how you get the sub hash. Right. Now, so we talked about the implementation now. I've also given you a structure code that you can use as it is. We have talked about the tricks also. Now some of the issues are left, right? So there are one or two issues. So one of the issues is hacking. So this is actually the, don't understand your approach. What part did you not understand? I think at least you understood this part. So did you understand this part? How we are storing the prefixes? Okay, after that we are just taking the sub hash, right? So I'll just explain once more. For the sub hash, it is nothing but we just have the int l comma int r, right? And this is our answer. So what else do you not understand? Oh, for the Codeforces problem, see, wait a sec. Just a minute. Right. Yeah, so in this problem, it was just that whatever string we have, we will always get the answer like this. We will have a certain string, and we will have the reverse of that string at the end, but we will have a palindrome somewhere in between. So what we want to do is we want to take the longest such palindrome, we want to merge it with this, and that's how we get the answer. So what part do you not understand here? How do we get this longest palindrome? Right, so you can use that thing. Just a second. Yeah, you can use that. Just wait a second. So, hashing with binary search approach that we earlier talked about. So you will know that from this center you have a palindrome of length 3, right? So since or you can use manager also, right? So you can I use manager in this. During the contest I use manager. You can use the hashing plus binary search approach also to get the longest palindrome from each center, right? So you know that this is a palindrome, right? And you need to use this information to mark whether this is a palindrome or not, right? In fact, from each index L, you want to mark the longest length such that this entire thing is palindrome, right? So just a second. Right. Let me see my code to see how exactly I did this part. There are multiple ways to do this, although. Okay. First of all, using this part, using this LPS thing, sorry, the longest palindromic substring, yeah. So the LPS thing, which is the longest palindromic substring, you can get this thing, right? Even with hashing, you can get, even with hashing, you can simply check if this string is palindrome or not, right? So from each index, you want to check the maximum R such that this entire thing is palindrome, right? So for that, basically what you can do is, okay, let's say if you have something like X, Y, Z, X, Y, YX, right? Basically, at this point, you want to store this thing here, right? You want to store 5 here, right? Because you know that there's a palindrome of length 5 that starts here. Okay. So basically, what you can do is when you find that there's a palindrome of length 5 here, you can directly put a 5 somewhere here, right? You can directly put a 5 here because you know that because since you know that this is palindrome, you know that there is a palindrome of length 5 that starts from here, right? But there could be something even longer. Let's say if you have a here, then you again have xy, zyx, right? So what will happen is for this a you have 11, so you will remove this 5 and put 11 here, right? So basically put the maximum value that you can put here, right? So point is, if you have 11 here, automatically you know that there will be a 10 here, there will be a 9 here, and 8, 7, 6, and so on. Wait a minute. 11, 9, 7, 5, 3, 1, and so on, right? So do you understand this? Just keep on decreasing it by 2 because you're losing one character from the end if you're taking one from the start, right? So do you get this now? Yeah, something like this. Anyway, so one of the biggest issues with hashing is you get hacked a lot. One of the biggest issues is hacking. I'll even show you one thing, what how big an issue hacking is. So the global round problem D actually, problem D2 that I just showed. So it got hacked a lot, and yeah, I was the one who was hacking everybody's solution. I think I hacked at least, I don't know, I hacked at least 20 solutions. And yeah, it happens a lot. Like there's a lot of hacking when you use hash. Okay, so I'll show that to you soon. But let's see how you keep getting hacked. So basically, if somebody knows your base and your modulo, so if somebody knows your base and modulo, then what he can do is he can run some programs on his computer, run some loops, use birthday paradox and things like lattice reduction, a lot of techniques. So he can use all of these things if he knows both your base and modulo. Even if you have multiple bases or multiple modulos or whatever, if he knows all of this stuff, he can make a counter case. So what you want to do is, you don't want to let him know this thing. Like even upon seeing your code, he should not be able to know your base and modulo, right? So how is it possible to make sure that he doesn't know your base and modulo even if he sees your code? Okay. How can you make sure that he cannot know your base and modulo even if he knows your code, even if he sees your code, right? So for this we use randomization. We randomize the base, right? We use a random base instead of a fixed base, because if the base is random, then it is not possible to guess the base, right? And why are we randomizing the base? Why not the modulo? What is the problem if we try to randomize the modulo? Right. So the problem with randomizing the modulo is that we want the modulo to be prime, and if we randomize the modulo, there's a very less chance that it will be prime, right? So to make sure that modulo is prime, we always randomize the base, right? So why do we want the prime modulo? We'll come to that a little later. But yeah, so if we randomize the base, and let's say if we have two bases or one base or whatever, if we randomize it, if somebody reads the code, he won't be able to know what base your code will have, so he cannot hack it. So so that's how you avoid hacking. You randomize the base, right? Now the last thing that is left is, why is modulo chosen to be prime? Okay, so the question is, why prime modulo? Okay, one of the reasons is mm, it has inverse. Okay, so this is one of the reasons. As I said, to get substring hash in the way I told, you need inverse. You don't always need inverse. Sometimes you can work without inverses as well. But yeah, in a lot of implementations, inverses are required. So that's one reason why you would use a prime modulo. But even if you have a implementation in which the inverses are not required, then also it is better to use prime modulo, right? Because mm, when you have a prime modulo, the hashes are more properly distributed. Okay, so when you have a prime modulo, the hashes that are there are more properly distributed, right? So what do I mean by more properly distributed? Can anybody point that out, what it is meant by more properly distributed? Okay, I'll explain. So it is something like, let's say, um, right. So let's say the modulo is a multiple of 2. Right. So we will see what the problem will be if the modulo is a multiple of 2. Right. So the same thing can be applied if the modulo is multiple of 3 or 5 or anything. Right. So but if it is a modulo, if the modulo is a multiple of 2, then there's a problem. Right. So in this way we can show for each number, if it is a multiple of a certain number, then there's a problem, and that's why prime modulo is the best. Right. So if the modulo is a multiple of 2, then there is a problem. And let's see what the problem is. So let's say if we have a string which has only characters like B, D, F, B, D, D, F, B, and so on, right? So it has only these characters. And by the way, the ASCII value of all these characters is even. This is 2, like these are not ASCII values, but like even the ASCII values are even. Like this is 98, this is 100, this is 102, and again 98, and so on, right? So basically all of them are even. Right, so all of these are even. So what is the problem if all of these are even? So basically, if all of these are even, if we try to multiply and add them together, then the result that we get, that will also be even. So it means that hash will be even. So what is the problem if hash is even? Yeah, I'll explain that. Just a minute. Okay. So what is the problem if hash is even? Okay. So yeah, this is the question that is open for everyone. What is the problem if hash is even? What gives 0? No, no, no. Modulo is just a multiple of 2. It's not exactly 2. Like modulo can be, let's say, I don't know, 100, right? So even if hash is like modulo can be something very, very big, like let's say 10 to power something, right? So if you take the modulo of some even number with this thing, it's not like you will definitely get 0. That's not the problem. See, the problem is if the hash is even, and since the modulo is also even, so the hash modulo m, the hash modulo m that you're calculating is what? Is nothing but hash minus some k times m, right? And since hash is also even, m is also even, this thing will also be even, right? So the problem with this thing being even is that the entire size of bucket is now halved. Earlier, what was happening is the hash was uniformly distributed in all of the 10 to power 9 buckets. Now it is distributed only in 5 into 10 to power 8 buckets. So that increases your probability of collision, and that is the problem, right? So if everything is even, then this will be the problem, right? But if m is prime, right? So then this means that this is not a multiple of 2, and this is a multiple of 2, and this can be anything. So if you do this thing, this may or may not be a multiple of 2, right? So even or odd. So it may or may not be even, right? So that means that the hash will be uniformly distributed in the entire domain. So that gives you lower probability of collision. So that is the reason, which gives you a lower probability of collision. Okay, right. Now let me tell you about the Placement 2.0 batch that is going to be launched tomorrow. So it is a 4-month course in which to basically teach you how you can crack product companies top like interviews of top product companies. The learning path is totally structured, so you know what to study, when to study, etc. And one subscription gives you access to all of these batches, like whatever these batches are, it gives you access to all of them. So this is going to start tomorrow. These have started already. Some of them are like really long. This is like a 12-month batch. Which makes you beginner to expert level coder in just 12 months. So it will teach you everything. But today we are talking about the placement batch. In this, you get live interactive classes. You can attend live interactive classes with our top educators, and you also get a list of relevant problems that you can practice after the class. And there's also a doubt support forum. So it is a in that there are expert teaching assistants like 6-7 star programmers. They help you solve all the doubts. And this is the batch structure of the 4-month batch. So since it is a 4-month batch, the number of topics aren't a lot, but these are all the important topics. In just 16 weeks, you will get familiar to all of this: basic data structures, advanced data structures, string algorithms, game theory, dynamic programming, and everything. Okay. And graph algorithms, previous interview problems, everything. So in just 4 months, everything will be taught. So these are the educators. Some are very well known, and you can read about their accomplishments here. So very talented and very proficient in their field. And yeah, finally, this is the cost of subscription. It is 33,000, but if you use my code, you get 10% discount, which brings it down to 29,700 something, which is less than rupees 90 per day. If you buy for 1 year, you can also buy for I think 6 months, because the batch is only 4 months. If you want to enroll in the placement batch, you can also buy for 6 months, 3 months, and then 1 month, anything like that. So yeah, that's that. And yeah, so that's it. And thank you for watching. If you have any doubts, you can ask right now. DP series, yeah. So DP series, I will continue soon. I was a bit busy these days, so yeah, I took string hashing because it is more like a standalone topic. I only had to do one class here, so I took it separately. But yeah, I'll do DP series soon. Okay, I don't think there are any doubts, so I guess I'm going to. Okay, so I guess I'm going to end this class, and yeah, thank you for watching.